We are moving past the hype phase of AI and, getting our hands dirty with the actual engineering. Yeah, for sure. Specifically, we are tackling how to build and configure LangChain agents. It's a huge topic. If you've been following the space, you know that for a long time we've treated large language models, LLMs, as these kind of magical text generators.
Right.
But if you strip away the interface, a standard LLM is basically a brain in a jar. A brain in a jar. That's a vivid image. Well, think about it. It's brilliant. It can write sonnets. It can solve complex math, but it is completely cut off from the world. It can't check the weather in London right now. You can't look up the live price of Bitcoin. It certainly can't update a row in your SQL database. It just creates text. It doesn't do anything. And that is exactly where the concept of an agent comes in. So that's our mission for this deep dive. We are going to take that brain out of the jar and give it hands and give it hands. Perfect. That's the perfect analogy. And because this is a technical deep dive, we want to structure this like a proper learning session. By the end of this, we really want you to be able to do, say, 4 specific things. First, you'll be able to define and configure the core components, the model, and the tools. Second, you'll understand the engine that drives the whole thing, which is the React loop.
And third,
We'll look at resilience, how to handle errors so your agent doesn't just, fall over when things go wrong. And finally, we'll cover how to structure the output so you aren't just getting chatty responses, but actual usable data.
I love that roadmap. It really feels like we're moving from just talking to a computer to having the computer do a job for us.
Precisely. And we're looking specifically at the create agent function, which builds this graph-based runtime using LangGraph. So before we dive in, let's activate that prior knowledge you might have. Start thinking about a script that runs top to bottom. Start visualizing a graph. You have nodes, which are steps like think or act, and you have edges, which are the connections. The agent is just a traveler moving through that graph to get a job done.
Okay, let's unpack this. We got the map, the graph. Let's start with the traveler itself, the brain, the model. I assume most people listening know what a chat model is, but how does it fit into this agent architecture?
So the model is the reasoning engine. It's the node in the graph that's responsible for creating the plan. Now, when you're building this with Create Agent, you have a really fundamental choice to make right at the start.
Which is,
are you building with a static brain or a dynamic one?
static sounds, well, easier. Is that the default?
It is. It's scaffolding level 1. You configure it once when you create the agent, and it just stays the same. You can do this super simply by passing a model identifier string. So for example, if you just pass OpenAI.GPT-5, LangChain handles the rest.
So it just knows that means go to OpenAI and use GPT-5.
Yeah, it supports automatic inference, but usually, in a real production environment, you want more control. You might want to set the temperature to 0 for precision, or set a max tokens limit.
Is so you don't accidentally spend a fortune.
Exactly. In that case, you pass an actual model instance, like chat OpenAI.
Okay, that makes sense. But you mentioned dynamic models. This is where it gets really interesting for me. Why would I want the model to change while the agent is actually running?
Think about like running a business. Let's use a real world analogy here. If you have a task like organize these files alphabetically, are you going to hire a $1,000 an hour strategic consultant to do it?
No, of course not. That's a massive waste of budget. I'd hire an intern or use a basic script.
Right. But if a client walks in with a complex lawsuit, you need the senior partner. Dynamic model selection lets the agent decide at runtime which brain to use. We do this using middleware, specifically a decorator called @wrap_model_call.
So the middleware is sitting between the agent and the provider.
Correct. You can write logic that says if this conversation has gone on for more than 10 messages, or if the complexity score is high, then swap the model.
So you could start with a cheaper, faster model for the simple stuff, and then if the problem gets hard, the agent automatically upgrades itself to something like GPT-4o or GPT-5.
That is the classic use case. It's all about cost optimization and sophisticated routing. It's like the agent is self-aware enough to say, hey, I need a bigger brain for this one.
I want to do a quick formative check-in for you listening here. Just visualize that shift. You weren't just hard-coding a single intelligence. You're building a system that can adapt its own intelligence to the difficulty of the task. That was a huge leap from a standard chatbot.
It is, but remember, a brain, even a dynamic swapping brain, is still just thinking. It's still in the jar.
Right.
Now we need to give it those hands we talked about.
The tools.
In the LangChain ecosystem, tools are basically Python functions or core routines. You use the @tool decorator to define them. But here's the part that trips people up. The code inside the function matters, obviously, but the doc string, the text description, is actually more important.
Wait, why is the description more important than the code?
Because the description is the user interface for the LLM. The model reads that description to understand what the tool does, and maybe more importantly, when to use it. If you have a getWeatherCool but your description is vague, the agent won't know it has hands.
So if I write a function, I need to explicitly say in plain English, use this tool to fetch current weather data for a specific city.
Exactly. That text is what bridges the gap between the reasoning engine and the actual code. And once you have tools defined, the agent can do sequential calls, checking stock, then shipping, or parallel calls, or even dynamic selection based on results.
Differentiated explanation here. Without tools, an LLM is a writer. With tools, an LLM becomes project manager.
Spot on.
Okay, so we have the brain, which is the model, and the hands, the tools. Now, for the part that I think is the most critical for everyone to understand, how does the agent actually know what to do? How does it connect the brain to the hands?
This brings us to our second learning objective, the React loop.
React, like REACT.
Right. It stands for reasoning plus acting. It is the loop that drives the whole agent. It goes reason, act, observe, and then it just repeats.
I think we need a worked example here. We should probably walk through this step by step. Let's say I want to buy, I don't know, a pair of wireless headphones.
Perfect. Let's say your prompt to the agent is find the most popular wireless headphones right now and check if they're in stock.
Okay. I am the agent. I get that text.
Yeah.
Step 1 is reasoning.
Yes. The model thinks it literally generates a thought process that says something like, okay, the user wants popular headphones. Popularity changes all the time, so I can't just rely on my pre-trained memory. I need to search external data.
So it's drafting a plan.
Correct. That leads to cycle 1, the acting phase. The agent generates a tool call. Something like search products, wireless headphones. Then the tool runs. This is the observation. The tool returns a string, maybe a list of products. Let's say for this example, it finds the WH1000XM5.
Okay, so the agent has the model name. Is it done?
Nope, because it remembers the second part of your request. Check if they are in stock, so we go right back to the start of the loop, reasoning.
Right.
The agent thinks, I found the headphones, now I need to check the inventory.
So it acts again.
It calls check inventory, WH1000XM5.
And the observation comes back. 10 units in stock.
Now the agent enters a final reasoning phase. It looks at all the data. I have the item, I have the stock count, I've answered the user's request. It then generates the final output to you.
So the loop continues until a stop condition is met.
Exactly. The stop condition is usually when the model decides it has the final answer, or, and this is important, if you hit a maximum iteration limit so it doesn't just loop forever.
That breakdown reason, act, observe, is so key. It's not just one big mashup, it's a really distinct process. But let's address a common misconception. We're giving this brain hands, but, sometimes hands drop things.
Right.
What happens when a tool breaks?
This is a huge one. A lot of developers think if a tool fails, the whole agent just crashes.
Right. If I divide by 0 in my Python script, the script dies.
In a normal script, yes. But in an agent, we can use middleware to handle this. Specifically, we use the @wrap tool called decorator.
How does that change the outcome?
Okay, imagine your agent tries to calculate something and accidentally divides by 0. Instead of the whole program crashing and burning, the middleware catches that exception. It then formats a special message, a tool message, that contains the error.
Wait, so it sends the error message back to the LLM?
Exactly. This is the aha moment for so many people. The error isn't a crash. It becomes an observation. The agent sees a message that says, error, division by 0, please check your input.
Oh, that is brilliant. So the agent can look at that and go, whoops, my bad, and then try again with different number.
Yes, it effectively allows the agent to self-correct. It creates a resilient system that can recover from its own mistakes without the user even knowing something went wrong.
That is a massive upgrade from a standard script. Okay, let's move to our third objective, configuration and memory. We have a loop running, but we need to give it a personality. Or, tell it how to behave.
That's where system prompts come in. The simplest version is just passing a system prompt string, like you are a helpful assistant. But for the power users listening, you can pass a system message object.
And why would I use an object instead of a simple string?
It gives you way more structural control. For example, if you're using Anthropic models, you can use system message to enable prompt caching. You can set cache control ephemeral.
Why does that matter?
Well, imagine your system prompt is a 50-page employee handbook. You don't want to re-upload that and pay for all those tokens on every single turn of the conversation, right? Caching tells the provider, hey, keep this heavy instruction block in memory. It saves money and latency.
That's a great tip for production. But what if I need the personality to change? Like if I'm talking to a beginner, I want a simple explanation. If I'm an expert, I want the technical specs.
You can use middleware again. There's a decorator called @dynamic_prompt. It lets you inspect the context, say the user role variable, and generate the system prompt on the fly. So if user role is expert, the prompt becomes provide detailed technical responses.
Man, middleware is really doing all the heavy lifting in these advanced configurations.
It really is. It's the key to making everything extensible.
Now let's talk about memory. We touched on it, but an agent has to remember what we just said.
Right, by default, agents maintain a sequence of messages. That's their short-term memory. But sometimes you need to store more than just the chat log. You might want to store, say, user preferences or a summary of the conversation.
And this is what we call state, right?
Yes, custom state. Now, I need everyone to pause and listen closely because this is where a lot of people get stuck. There's a big warning here for anyone who's used older versions of LangChain.
Go ahead. What's the trap?
As of LangChain 1.0, and specifically in LangGraph, you cannot use pedantic models or data classes for your state schema anymore. You must use a typeit.
Oh, wow. I know a lot of Python devs love their pedantic models. So if I try to pass a pedantic object as my state, it's just going to break.
It won't work. Your custom state has to extend agent state as a typeit. It's a strict requirement now for the graph-based runtime.
That is a crucial formative check. So if your code is throwing errors on state, check if you're using a typeit.
Precisely.
Okay, we have a resilient dynamic agent with memory. That brings us to our final learning objective, advanced outputs. At the end of the day, sometimes we don't want a chat response. Sometimes I want data. I want a JSON object I can just stick in a database.
This is where structured output comes in. You might want the agent to extract contact, info name, email, phone, and give it to you in a clean format, not buried in a sentence.
So how do we force the agent to do that?
You use the response format parameter. And again, there's a nuance here. You basically have two strategies, tool strategy and provider strategy.
Can we break down the difference?
Tool strategy is pretty fascinating. It uses what's called artificial tool calling. It kind of tricks the model into thinking it's calling a tool that requires those specific fields, name, email, phone. And the cool part is it works with almost any model that supports tools.
And provider strategy.
That uses the model provider's native structured output capability like OpenAI's JSON mode. It's generally more reliable, but it only works if the provider explicitly supports it.
So decision time. If I'm using a model that has native JSON support, I should go with provider strategy. If I'm using something a bit more generic, tool strategy is my backup.
Exactly. And just like with the state schema, simply passing a raw schema isn't supported anymore. You have to explicitly wrap it in one of these strategies.
Okay, let's zoom out. We have covered a massive amount of ground here. Let's try to synthesize what we've built.
We built a complete cognitive architecture. We started with the brain, the model, and we talked about how to make it dynamic. We gave it hands with tools. We walked through the dance steps of the React loop. Reason, act, observe.
And we made it bulletproof with error handling middleware, configured its memory with typeit, very important, and ensured we get clean data out the other side.
It's a complete system. And for the transfer part of this lesson, how do you actually apply this? I'd ask you, the listener, to stop looking for places to just put a chatbot. Instead, look for processes.
Processes.
Yeah. Instead of just answering questions, where can you build a graph that performs a job? Can you build an agent that monitors your emails, categorizes them, and then drafts responses to the urgent ones? That's just a React loop with an email tool.
That's the key shift. It's not about retrieval anymore, it's about execution.
Right. And this leads me to a final provocative thought I want to leave everyone with.
Let's hear it.
We talked about using middleware to dynamically swap the agent's brain based on how hard a problem is. So if we are building software that can assess a problem, choose the right level of intelligence to solve it, and then execute the solution. At what point does that software stop being a tool and start becoming a manager?
That is a profound question. When the agent starts managing its own resources and strategy, the line blurs quite a bit.
Something to chew on while you build your next agent.
Thanks for listening to this deep dive into LangChain agents. Go out there and give your brain some hands.
Happy coding!